Good morning, madam. I'm Naavind Balan from Industrial Power. So today I would like to present about the control and uncontrolled full wave rectifier under power electronics. It's a lab 3. So I'm Naavind Balan. I just now already mentioned about this thing. So today I already constructed a circuit based on this one on LT-SPICE software, and then the result for the this thing sine 021k for the resistive load, and then for the inductive load, and then capacitive load and capacitive load. So I already find input and then the output voltage and then the average voltage in the below. So for the average output voltage is 11, for the resistive load, inductive load is 11.171 volt, and the capacitive load is 18.288 volt. The capacitive only is 18.556 volt. So this is the input value. So I already get 20, 0 to 20, and then 20 to negative 20, and then back to 0 for the one cycle. So this is my circuit, and then for the output for the resistive load, I get like this. So the value from 0 to 18.26. So the average is already 11 point something. The circuit is here. So for the inductive load, so my value is from below negative 0, that is negative 1, to 18, and then back to negative 1 for the inductive load. And then for the capacitive load, my waveform is like this. I will connect it in parallel the capacitance and the resistance with the power supply, the full wave diode, and then this is for only capacitive. So I will get like this. So the input is over here, and then the output. So the average also I already mentioned in the above. So the capacitive and then the voltage for the full wave rectifier. So for the discussion part, explain and the independent characteristics of the large inductance in the DC and AC is because the current is constant in a DC source. The inductor acts as a short circuit element, conversing and transmitting energy in the circuit but not generating it. It will perform as a resistor in a AC source circuit, resisting current flow to reduce a voltage proportionally to a rate of change of current for the first question. And the related your discussion in one with the capacitive or inductive in the filtering output current ripple. Circuit with the inductive can block or modify alternating current or a varying of a sinusoidal frequency. It can be used as a filtering circuit to filter current fluctuations. Often known as a current peak, it is because of inductors positions is proportional to the supply frequency starting at the at as a supply the reactive rectifier output, allowing the DC component to react the load. So explain the impedance characteristic of the large capacitive in the DC and AC, which is constantly charged or discharged, whereas in an AC circuit, the capacitance of a capacitor is determined by the frequency of the frequencies of the input signal, which is constantly charged or discharged, and the capacity also charge and discharge. Related your discussion in 3, which is the capability of a capacitor in filtering output voltage ripple. By charging the ripple voltage into a smooth DC voltage, a rectifier can reduce a ripple. Low frequency signal will be filtered out by the capacitor. The frequency of this signal will be close to 0 Hz, and they are all classified as a DC signal during filtering output voltage ripple, and capacitor is often used to filter unnecessary frequency. Conclude your findings. Based on my conclusion, a full wave rectifier can convert both halves of an alternating wave of AC signal into a bursting rectifier. In a full wave rectifier circuit, the current of the capacitor and or inductors operate as an filter to decrease a ripple voltage, resulting the graph shown above. While it just flow in AC circuit but prevents the DC signals. For the design questions, I already done the circuit. So for power supply and the diode and transistor, voltage supply for the thing and the resistor, I already connected 60 millisecond because I done for three uh, peak to peak. So the sign like this for 3 cycles, and then the output should be first, it should be over here to supply in U1, and then the resistor to get the first cycle, and then for the not for the first cycle, it for the first wave, and the negative part it will go to this side and it will be block this transistor, and it will go here, it will be nothing, just got sudden drop over there. That's all. Thank you.